Hail. This would be for Wednesday, April 8th, obviously. Let's start with some reminders about exponents. So this would be on like the first handful of problems, right? So you have to remember when to add powers. When you're doing something like m to the second times m to the third, you use the shortcut of adding the powers. Okay, and 2 times 2, that's just regular 2 times 2. Just like down here, 4 times 2, you can multiply those together. Like you learned back in second grade. And then n to the fourth times n to the negative third. Same base, each with a power, and if you're going to multiply those together, again, this is where you add the powers. 4 plus a negative 3 is positive 1. Alright, let's see, remember here that a 0 power, which happened because it was y to the negative third times y to the positive third, and then when you added those powers you got a final power of 0, but remember, anything to the 0 power is completely equal to 1. So this whole thing got replaced with just a 1. Alright. And here, I almost didn't see this. I mean, I wasn't going to forget about this, but might as well use this example here. Remember, a negative power, you're not really supposed to have negative powers in your final answer. So you would take this like r to the negative 1, and you can move that base down to the denominator, and the negative power becomes a positive power. Now the 8 does not have a negative power. This negative 1 power only applies to the r. This 8 has technically a positive power of 1, so the 8 stays in the numerator. And it's only the r that drops down to the denominator so that it can have a positive power of 1 then, okay? Anything else here when it comes to powers? So this one ended up being a little bit different because the 2 was also going to have see, this negative 4 power also applies to the 2 as well as the x squared, okay? Now, another thing about this problem to remind you of, okay, is that when you are doing a power to a power, see here it was like x to the second to the negative fourth, and it was like immediately raising a power to another power. That is where you multiply powers as a shortcut. Anything else that I wanted to say from these problems? I mean, you can pause the video and analyze these answers, and hopefully the work can speak for itself a little bit. Notice again here the 12 stayed in the numerator, but the a and the b moved down to the denominator to make the negative 1s into positive 1s. But here it was the 2 had a negative power, so that got moved down there also. And if there's nothing, I mean, it's not really going to be nothing left in the numerator, it's going to be a 1, so you could have a 1 in the numerator if there's nothing else. There's one more, maybe it won't even be on. Alright, here we go. So this, remember, when you're doing like r to some power divided by r to another power, when you're dividing with like bases, like we are here and like we are here, that's where you subtract powers. So 2 minus 3, that's negative 1. Okay? And this 2 just kind of stays in the denominator. Okay? So when you subtract powers, the result of that is in the numerator. So that's why here we have r to the negative 1 in the numerator. Of course, in this next step, we have to now fix this negative power, make it into a positive power by moving this down to the denominator. But again, when you subtract powers like here, so 4 minus 3, that would be n to the 1 power, the first power. And then 3 divided by 3, that's just regular numbers that are being divided. That's just 3 divided by 3, which is 1. Alright, so I think that covers all the reminders about properties of exponents. So again, so to summarize, I guess, you have to know when to add powers, which is like here, v to the second times v to the second, v to the fourth. That's when you add powers. When you multiply powers is like right here, when it's a power to a power, that's when you multiply. And when you're dividing with common bases or this like bases, that's where you subtract. And then you also have to remember how to deal with a negative powers to fix up your final answer. And you have to remember what a zero power means. Zero power, whenever you're raising something to the zero power, it's 1. Alright, other quick reminders. Just remember about how to distribute. Like here, if you're multiplying this 6v term times this bubble of terms, and there's 2 terms in here, you have to distribute the 6v, which means you're going to multiply 6v times 2v, and you're also going to multiply the 6v to the positive 3. So 6v times 2v is 12v to the second. Technically, you're adding the powers on the v's. Okay, v to the first times v to the first is v to the second. And also remember, when you're doing a bubble of 2 terms times another bubble of 2 terms, you have to do all of this distributing. You have to distribute the 2n through this second bubble, and you have to distribute the 2. So it's like taking the distributive property to the next level. And you get all 4 of these terms from all of this multiplying. And then there may be, there's probably going to be, I dare say there's probably, very likely going to be some like terms that you have to combine to kind of clean up your final answer. Why don't I run through this one step by step really quick. So again, like a term or a bubble of 2 terms, like a binomial technically, times another binomial. And so we do 4n times 2n to get 8n squared, and we do 4n times 6 to get 24n. And then we do 1 times 2n to be just 2n, and then of course 1 times 6, or to be more specific, positive 1 times positive 6 is positive 6. And then you look at this and you realize that 24n plus 2n are like terms. They can combine to become 26n for your final answer, along with the 8n squared and the positive 6. Just remember, like a problem number 19 is just taking it to the next level, I guess, a little bit. You have 2 terms here, a binomial, times a bubble of 3 terms, a trinomial. So there's just more distributing to do. You got to distribute the 4a to all 3 of these terms in this other bubble, and then you also have to distribute the 2 and multiply the 2 to all 3 of these terms to get all of these answers. You know, 4a times 6a squared, that becomes 24a to the third, because technically you're adding powers when you do a to the first times a to the second. So you get 4 times 6, which is 24, and then a to the first times a to the second, that's the a to the third. And then we keep distributing. 4a times negative a, that's negative 4a to the second. And then 4a times positive 2, 8a. And then distributing the positive 2, we get all 3 of these answers. And then there's like terms, right? Negative 4a squared plus 12a squared, that gets positive 8a squared. And then positive 8a and a negative 2a, those combine to become 6a. And then the 4 Nothing combines with the 4. Nothing combines with the 24a to the third. And so there's your final answer for that.